So the bands of the sensors that acquire remote sensing images are mostly in the atmospheric window, the section of the electromagnetic spectrum that experiences minimal absorption or scattering. This is the section of the atmospheric window, which has the infrared region as well as the visible region. And the easiest way to remember the band order is to follow the color gradient. As we have seen in the earlier section, it starts with approximate blue, green, red, and then R, right? Orange is generally not used, and yellow is very rarely used in remote sensing data. So it kind of follows the childhood acronym that we learned to remember the 7 colors of the rainbow, that is VIBGYOR, right? Similarly, similar kind of trick can be applied to remember the bands of remote sensing data. Because generally, they start with lower wavelength, that is blue or close to blue wavelength, and then move to higher wavelength, that is red or infrared, or even beyond the near infrared region, right? Just for information, generally, visible ray, visible section of the electromagnetic spectrum, infrared region, and microwave are the most exploited section or the part of electromagnetic spectrum that is utilized in remote sensing. Other sections are not utilized enough or hardly utilized. So if I were to project what are the bands that are used, so these are the general used bands utilized, and the sequence follows like so: blue, green, red, and then NIR, or any from infrared region, right? Landsat has 7 bands: blue, green, red, NIR, SWIR1, thermal, and then SWIR2. SWIR is shortwave infrared. It is beyond the near infrared. Near infrared is very close to red, right? As the sequence goes. Shortwave infrared is within the infrared zone itself. So is thermal, but this one is much more closer to near infrared region. And all these sequence follows wavelength number. According to that, we determine whether it is SWIR1, SWIR2. See, wavelength values are given here. Approximate wavelength values for you to remember is, if you generally take your knuckles, there are 4 knuckles, and the spaces in between them are 3, right? So you can just go, or you can use the fingers for that reason. Start with the base, 400, 500, 600, and then 700. These 4 lines on your finger forms the wavelength values, which divides the visible spectrum into 3 parts. The base is the blue, then green, and then red utilized. So this is a kind of trick that I just told you. So after Landsat, we can also see in list 3, there are 4 bands: green, red, NIR, SWIR1. And in list 4, there is 3 bands. You see, all of them follows the same sequence, that is blue, green, red, NIR, lower wavelength, then higher wavelength, right? Same here. As well as in PS-Gov, that is 3 meter resolution, it also has the same sequence. Coastal aerosol is a section of blue wavelength itself, which is much more specific. And you see green is divided into 2. It is because there is a difference or a change of wavelength. And both of them have different uses. Yellow is also used. But you see the sequence? It follows the childhood acronym VIBGYOR. Blue, green, yellow, red. NIR. And red age is a band in between. It is very essential for estimating the health of or the chlorophyll content of the trees, which determine the vegetation stress or the vegetation health, right? So, but the sequence, you see, it's same. Now, how to remember it? Because when we visualize our maps, there are only 3 guns. Within these 3 guns, in multispectral I'm talking about, we have to depict our map. But as we saw in the last slide, a lot of bands come with the data. So how to understand what is happening with this visible spectrum as we have only 3 guns? So the first one, which is the true color composite, here, as the name suggests, true color is depicted by the color gun. Remember, we don't distort the visible range because that is fixed. by nature, by physics, right? The only thing that we can change is the guns. These three guns are the visualizing aids in remote sensing. These are the only things that can be changed. For example, if I want to visualize something as per my requirement, I can swap this this gun, which is now depicting in TCC in blue, by NIR. I can do that. But generally, what is done is we just slide. As are you able to see the transition? We just slide the visible spectrum a little bit, and we visualize green with blue gun, red with green gun, and NIR with red gun. Clear? And this is called the standard false color composite. It is most widely used and standardized form to use while visualization as well as for land use land cover classification. This is the base reference map that is utilized mostly. But according to our need, we may choose to depict in a different way, which is also valid. That is called false color composite. Mind you, false color composite can be any combination according to your need. And all of them are documented in Landsat's portal as well as other geospatial portals. And their use is also enlisted there. So as you can see, as we further slide this range, blue gun is showing red, green gun NIR, and red gun SWIR, 1 or 2. Like this, we attain this particular type of FCC. False color composite, as I said, can be multiple types. You can choose one according to your need, and all of the combinations are well demonstrated, documented in different geospatial portals, USGS being one of them. Right? So I hope this video was helpful. If you find this helpful, please comment down and let me know on what topics would you like me to make a video. Thank you so much.